So we're going to go ahead here and do the stab alignment. Our former's nicely glued in there. Everything's set up nice, so that's how I took all that apart. No real issues. So to do the alignment, a couple things. You need to get the fuse and the stab perpendicular, right? So essentially, we want this tail post and then the center line of that stab trailing edge to be perpendicular. So there's a few ways you could do that. You could do it off your table, right, where you square that fuse up to your table with a square, and then measure up to each tip on the stab half. Make sure they're equal. You need a nice flat table to do that. That's perfectly fine. What I'm going to do is I'm going to use a plumb bob. So basically a string with a weight on it, nothing fancy. I'm going to hang that off my ceiling. I've got a roof rack over my bench that I can easily tie that to. And so I'll use that to set the vertical, the fuse vertical to that. And then what I'm going to do is I'm going to use one of these guys as a self-leveling laser level. This is a Bosch one. It fits on a tripod. It's got a screw there, so a tripod mount. Once you get the thing disengaged and turn on, the cross on the laser automatically self-levels. So they're pretty accurate, I find. You can kind of see if I turn that thing on there, it kind of sets to level, you can kind of see it bouncing around there, and it basically stays level on its own. So this way I don't have to mess around too much with measuring. I can just set that up on the plumb bob, shoot the laser on the string, and then basically as long as my tips on each stab half are got laser light on them, it's pretty close. And once I get that done, then we're going to do an alignment square to the fuse. So for that I'm just going to use some string, just any kind of string, and I'm going to hook that string basically up to the front of the fuse here, and then just go back to each stab tip and make sure each side is the same, and just do some slight adjustment on that. And that's really will be the extent of my alignment. Once that's sitting in a happy spot, all those measurements line up, we'll tack glue the socket in place, and then we'll do all the finished gluing afterwards. Some people, you should also check the distance from the root of the stab out to the tip. Now, for me, I'm not going to bother doing that. The foam comes cut, right? I mean, it's basically this distance to this distance on each foam piece is exactly the same. So I'm not going to bother. You see, they're exactly the same. So I'm not going to bother to measure that, because I know if they're butted up against the fuse, and I'm going to use some spacers in there to make sure that that's touching the fuse, that they'll be exactly the same measurement from the root to the tip. So there really is no point in my mind in doing that. These are some of the reasons why I don't cap everything first. Some people might do the capping first. I don't do the capping first. I want to do all this alignment first, so that I'm really taking all the measurements off the virgin panels, and then I'll do the capping afterwards. If you do the capping first, when you're sanding stuff, and even just the wood itself, you could be a millimeter or 2 or 3 millimeters difference at the tip then, and that really will amplify any misalignment. So if you're measuring from the center of that fuse back to the tip, if this tips out a little bit here, that can seriously make you think your stab needs to be adjusted in alignment, when really it probably doesn't. So that's why I don't do any of the capping. I'll get all this alignment out of the way, and then we'll do all that capping afterwards. So first thing, I got my center line of the stab marked on there, and I did it on both sides of the fuse now, so I just put some tape on there and got that center line marked on both sides, so you want to go ahead and do that. I just really eyeballed the center of this tube. It's close enough. And then what I did is I took the stab, put it on the tube. I drew where the bottom of that airfoil is going to sit. The reason why I did that is because I'm going to take a block of wood and just tape it to the fuse like so that when the stab is sitting there and everything's squared up, it's not going to move around on me. I don't have the anti-rotation pin and I don't have the adjusters in. I don't have any other mechanism to kind of keep that stab from moving around. I don't want to tape it because I don't want to put any kind of external pressure on the stab that might force it into some alignment. I want it to sit there relatively free so I can just very subtly adjust any misalignment before I glue it up. So just by luck, you know, there's a couple of big blocks of wood in the kit. These are actually the rudder capping top and bottom. So just take those out. I'm going to tape them to the fuse here and get that ready. Okay, so I went ahead and kind of set this up off camera. So what you see is I got my plumb bob hanging here and I got my fuse up against it. Now you do have to shim the fuse and align it in order to get it, obviously, the vertical portion of the fin straight up and down that plumb bob. Now a few little details. So you want that string and fin to be fairly parallel to each other, and you don't really want the string touching the fin. So you have to adjust it kind of fore and aft, the fuse, and you got to give time for your plumb bob to settle. It does take a minute or so to sort of calm down. And then I also weight the fuse up a little bit, put some weights in there, and there's my shim just to get the fuse vertical to the plumb bob. So the weights really just help it to stay stable, and that shim is just for the alignment. Now I've also gone ahead and I've put a little screw, as you can see there, into the center of the fuse. Now the mold line is not always exactly the center, it's pretty close, so just you need to kind of measure that width. And that's going to be my little hook point for my string to do the left and right kind of angular alignment. Those are the blocks taped to the side just to support the stab when I get that point. Yeah, this is a bit finicky. You're going to be kind of back and forth doing this quite a bit. You might bump something, but that's just sort of the nature of the beast doing this part. This really is my string here for doing the left and right. I just made a little loop that I'm going to use to hook into the screw at the front, and then the other end is just nothing. I'm just going to use my finger on each side, and when they're the same, they're the same. You don't need to measure it. It doesn't really matter what the absolute measurement is. As long as it's equal, that's all you really care about. Okay, so I've gone ahead, I've put the socket in the fuse and ran the tube through. If you got to sand the socket a little bit to get it in there, just so it's not rubbing and pushing on the fuse, and remember you got the former in there, so it's pretty firm on the width. You can't really flex that fuse anymore. Go ahead and do that. Doesn't really matter. If you have a little gap in there, no big deal. That whole socket down the road is going to be covered in microballoons and epoxy and fiberglass. So any gap in there is going to get all filled in anyways. So we'll do that once we get it set in place. So not a big deal for the gap. So to go about setting the stab on the plane, again, you need the spacers. Now, at this point, you want to make sure that spacer is the same on both sides. Do not use different width spacers. Do not take a spacer from one sheet of balsa to another. You want to cut them from the same sheet of balsa so that you know they're the same width. If one side is slightly further out than the other, that's going to cause you, not only will your stab be off center, but it will be misaligned because in this direction as well, because the measurement from the center to the tip is not going to be proper for both sides. When it's actually straight, it would be different. So you got to make sure that this spacer is right. You also got to make sure that you're touching the fuse, you're not butted up against the tube. So make sure the spacer is wide enough in order to get that stab tube out of the end caps. So you're really referencing off the angle of the fuselage. In my case, these are about, I think these are 1/4 inch. So That's what seemed to work there. The end goal here is really to have that stab in the same position it's going to be in when you bolt it up to go fly it. So we'll go ahead and start doing that. So we'll set these stabs on each half here. Let me make sure I got the right and the left. Let's see, I didn't, that's the left. That was almost a boo-boo. So we'll set them on there. So see, I got a bit of play in there. And I may have to put a little weight on that just to make sure that it's resting on my wood properly. I'll do this side now. I'm just going to put a couple little small 7-gram weights on them. You do want to make sure that your blocks get that stab in the center. So you may have to just adjust them a bit, tweak them up. And the reason why that's important, because we're going to use that laser level to shoot a laser on the trailing edge. If the stabs are different on each side, you can imagine one trailing edge will be lower, one trailing edge will be higher. So you would think that potentially you're misaligned when really you're not. So you want to be as kind of precise on those little details as you can get. So there's a bit of back and forth and fiddle work, but at the end of the day, when you get a nice straight airplane, it's worth it. As you can see, it's pretty much straight centered in the bottom and it's straight centered in the top. You know, I'm sure a millimeter or two isn't really the end of the world when the wind's blowing 25 kilometers an hour or 30 or 40. I really doubt you can probably tell, but the more perfect it is, you know, at this stage, just the better off you'll be getting it all set up and trimmed out properly when we start flying it. So I'm going to go ahead and set the laser level up, and then we will see just how close we are right out of the gate. Okay, so I've quickly set up my laser level on my other tripod and lined it up. Basically shot that laser on the plumb bob, and as you can see, if I zoom in here, you can see that laser is right on that plumb bob, and it is all the way up. So those laser levels, you know, I mean, that plumb bob is set vertical by gravity. Laser level set vertical by gravity. I don't know how more accurate you really are going to get. And this is the point where I'm going to show you or demonstrate, I guess, just how unbelievably perfect Pascal does these airplanes. I haven't done anything. I haven't touched the parallelism of the stab. I haven't put weights on it. I didn't do something off camera. So I'm going to scroll over here. So there's the one tip. You can see the laser level on that. I do have my overhead LEDs on, so I'll shut those off, maybe make it a bit easier to see. You can see that one tip laser, and then the other tip, you can see the laser. Now that one's maybe a little bit trickier to see, but if I turn that on, you can see that's basically on the money. So really, you know, it's just kind of just on the sheeting, and both of them are just on the sheeting. I don't think I would even adjust that. It's probably within sub 1 millimeter kind of a measurement. It's certainly within the width of that laser line, which I don't think you can get a lot more accurate than that. And, you know, double check that your plumb bob's looking straight through the center of the fin, which it still is. That's really all I'm going to do for the parallelism. So now we're going to come along and we're going to check the square on each side here. So we're going to go ahead and check that angular alignment. Now this is a little tricky. You don't want to pull. I don't want to pull too hard in this because I don't want to pull the fuselage over. But I just want to make sure that both sides are the same. So I'm going to set the one up, and now this may be a bit tricky in the sense that I gotta keep that in the same spot. And I'm going to go on the other side now. And you know what? They are super close. So I'm just going to double check, go back the other way. I usually do this 3 or 4 or 5 times over just to make sure that I haven't accidentally missed something. So I think when you got it close, you know, double check back that your parallelism's still the same, which if you haven't bumped anything, it should be. And mine's still pretty good. Really at this point, we can tack glue in that socket. Okay, so I went and taken my plumb bob out of the way, moved my laser level. I did do a few more double checks just off camera just to make sure I was happy with it. It's very, very close. You know, it's maybe not always exactly 100% perfect, but a millimeter or two I think is close enough. When we do the wings, not only will we do the wings back to the stab tips, we'll also do them back to the fuse, the edge of the fuse here as well, just to validate that not only are we square to the stab, the wings are also square to the fuse, so we can kind of make a couple of different checks that way. The stab parallelism, I think, is the most important part because we will use the stab to parallel the wings up to the fuse. So as long as we got that as bang on perfect as we can get, then the wings will be perfect as well. So really at this point, all I'm going to do is I'm going to set this in with some medium CA. I do have a long tip on there so I can reach it. We're just going to lock it in place, kick it up, and then we'll take everything apart and we'll go to work on doing all the glass and microballoon reinforcement and getting the anti-rotation pin into that front section as well. Get a good shot on it initially, and then we're really going to let that set up. You don't want to try to take it out too early and damage your alignment. So give that some time just to kick off. Maybe repeat the gluing a couple times and then very carefully dismantle your stab. Okay, so now that we got that socket set in place with some CA, and I did go back after the video and just put a little bit more CA in there just to make sure it's not going to move around. Now we're going to basically set everything in place with some fiberglass. So a few things. We're going to use the tube in the socket because we probably have a little bit of a gap between the fuse and our socket, so we're going to use the tube to make sure that we don't get any epoxy down inside that socket. So to do that, you want to make sure the tube's not going to stick into the socket. So I put a little PVA. So PVA is that green liquid like this. It's a parting agent. Just spread it on there, a couple coats of it. It takes about 20 minutes to dry. It's water soluble, so it'll come right off afterwards. I just did sort of the center section. That way the tube won't stick to any glue. Very important because you do not want to get that stuck into the socket or you will have a bad day. This is our anti-rotation pin. I did cut this down a little bit. We are going to set this and glue it into the fuse. So I've measured it out, basically the width of the fuse plus the bit that's going to go into each stab half. And really all I did for that was I just used the depth of that recessed into the foam in there. So that was about 17 millimeters. And I'm going to cap this with 1/8 of an inch, so about 19 millimeters. I guess would be the amount you need to leave sticking out at each side of the fuselage, just to give you that full penetration down into that stab adjuster area. So I've done that. We're going to use this epoxy. This is silver tip. I mean, there's all kinds of different stuff available. West Systems, System 3, you know, whatever you can get your hands on. But you really want a good, just sort of epoxy for doing composite work. I'd avoid using the 30-minute or anything like that. This stuff's a bit more thin. It, you know, penetrates the glass good. And then what I'm going to do with that is I'm going to mix it with two things. Some micro balloons. This, so you can get this stuff here locally, big jug of it, so you'll never run out. And then anti-sag, which is Cabosil, right? So this will just stop it from running. So I'm going to use that mixture, sort of that filler mixture, in and around the edges of the socket and around the anti-rotation pin. And then I've got a bunch of glass cut out here, so I'm going to put the glass in with the epoxy without the filler, all the way down the edges of that former and in and around the socket, the anti-rotation pin. So when all this is done, it's basically filled in and glassed over. It is never coming apart. So that's why I do that. A couple little tools. Again, your fancy stick with a brush on it so you can reach down inside there. I've got another fancy little carbon stick here in order to help me shove some of these pieces of glass down there. You are working in a pretty confined spot, so it's not the easiest place to work in. And then a few extra brushes I've got here. And you'll need some mixing cups and whatnot, popsicle sticks, just to mix everything up. Okay, so we're going to mix up the epoxy. I do wear gloves for doing this. These are nitrile gloves. I got a couple measuring cups here, or not measuring cups, but mixing cups. I am going to take my watch off because that would suck. This epoxy is a 2-to-1. I'm going to mix it by weight. I think weight volume, it's probably close enough. So take your cup on there, tare your scale so that your cup's reading 0. And I'm just going to take a ballpark as to what I'm doing here. So there's like 31 grams, which is probably tons. I like to clean the tops of these containers off because they seem to get stuck. The hardener seems to be worse. So I'm going to put 15 grams of hardener in here, so we end up with 45, give or take. This is actually pretty way too much, but so it's a bit of an amber color. You can see this stuff, this stuff's pretty runny. That's kind of what I'm going for there. Why you don't, hobby epoxy, the stuff 5-minute, 15-minute, it's not the same stuff as this for sure. And when you put the micro balloons in, it'll really fill that out. So that's probably quite a bit. I probably don't need that much, but yeah, probably a little bit less than there. So I've saved that. I'm going to use that to basically do the fiberglass work with. And then I'm going to mix in my micro balloons first. And there's no recipe for this. I just kind of do it by feel. See, it's kind of that marshmallowy texture there. So that's pretty okay. That's tons. It's more than I ever really need. So then, cover this back up, because if you spill one of those jars, it will also be a very bad day. So this is Cabosil, so it looks a little bit different. It's kind of these chunky little things. So this is I don't know what they call it, thixotropic, whatever. So it stops it from running. So if you want to basically have it filled and light and not run, you need to use both. So you notice now, is this stuff now is, it kind of doesn't move. It's sort of going to stick on a vertical surface, and that's really what you're going for. Because we are going to pack this around that socket. So we're going to mix this up really good. Make sure we don't have any sort of leftover. Okay, so she's nice and thickened up there, which is what I want. So I'm just going to use my popsicle stick here, and then I'm probably going to end up getting my fingers in there to do it, but use my popsicle stick, take some, and I'm going to basically work it in and around that socket. Say it doesn't have to be super perfect at this point in time, but we're going to work it in there. And really what we're trying to do is I'm just trying to fill all the gaps. I want to get that all in there nice so that it's just packed in there. And I got a good bead of microbloons in there, so I'll just sort of slowly work it in there with my finger. And as I do that, I'm going to pull some back out because we don't need all that in there. I'm trying to make a nice fillet. So I've kind of packed it around both sides. Again, doesn't have to be perfect or pretty. Just trying to get it. Whoops, see, I've glued that in pretty solid because I didn't break it when I did that, which is good because that would have really sucked. And so now we're going to do the front one. The front one's a bit harder to reach. I'll need my one of my tools to try to get across that one. So I'll just take this guy here. And really I'm just going to put this up on the top of the anti-rotation pin. Now the anti-rotation pin does not have any PVA on it. It is permanently glued in. Look inside there, I'll show you the anti-rotation pin. Maybe you can see it way in the back there. Basically what it looks like, kind of just gooped up, and there's our stab tube kind of gooped up. We're just filling in all the corners. Don't worry if it's not all neat and tidy and all the, they're probably going to get some epoxy here and there and everywhere, so we'll clean that up afterwards. To do all the glass work, I think it's easiest to put a bit of resin onto the wood and the sides of the fuse where it's going to go first, because that'll help it to sort of stick to the fuse. So I'm just going to go ahead and do that, and I'm going to get as far as I can in with this brush, and then I'm going to have to move to my other brush. Now I'm going to try, this is always a fun part, use my tool here to position this guy. So you can kind of see our glass in there now. This can focus. Kind of in the corners. So I'm going to go back and I'm going to touch that up with a bit of with some resin on my shtick here. So put a bit of resin on the brush, and we're just going to make sure that we don't have any glass showing. So there, that's done. It's all basically wetted out. So now where the tube is, and that's what I've got these kind of bigger pieces for, I'm gonna actually go right over top of the tube with these bigger guys here, just to make sure that that tube is really, well secured down. So what you really are left with when you do that tube, right, is you kind of end up looking like that. So come on, camera, focus in there. There you go. Right, so you should end up with sort of a nice smooth fillet around that socket. And this is why I got the PVA on the tube, and I wasn't too worried about a little bit of gap on that socket, because it's all basically filled in now and it ain't gonna go anywhere. So we're also gonna do the same with some glass on the anti-rotation pin. So again, I'm gonna take the wide one. So now that I got that one done, I'm also gonna go in there and I'm gonna do up the sides of the vertical former bit. So I'm gonna put some resin on that as well. Okay, so my camera died there from, it said it overheated. I don't know. First time I've seen that. Anyways, I finished up. I didn't want to stop while I was in the middle of it. I kind of got the best I could down at the back there. It's pretty tough. I did get like a couple pieces sort of in the corner, jammed in there of the vertical former. And then also on the anti-rotation pin, I got that. It's not pretty. Like, it doesn't have to be pretty. Nobody sees this except for you. So, and then the stab tube is in there nice. I'm gonna focus maybe. There it is. So the stab tube's in there good. So she's well supported. Can't go anywhere. A couple layers of fiberglass. So this is gonna cure up overnight. So we are not gonna touch that assembly now until tomorrow. And then tomorrow we'll take it apart, pull the stab tube out. Hopefully it's not stuck in there. So I do end up with a bit of microbloons left over. So before these cure up, and they are curing up because they're getting warm, I'm gonna make a little tail wheel support. So just a couple pieces of 1/4 inch light ply glued together, tapered off just to fit in there. So I'm literally just gonna goop this in here. And then I'm going to press this guy down in there. And again, you want to leave some space for your tail post. If your tail post is going to interfere with this, it doesn't really matter. You can always cut into it a little bit and overlap it. Not the end of the world. In fact, it's probably good for the joint. Anyways, that'll wrap up for today. I'm going to let all this stuff cure up overnight. We'll come back tomorrow.